Hello students, welcome on this video lecture, and in this video we will be doing some examples related to the projectile motion that we have gone through in the previous video lecture. So some of the examples first we are going to take, and later on we will be moving ahead with the theory aspects. So this is the example. You can pause and solve and then check your answer. So it says a projectile has maximum height given to us, which is h, and range is capital R, that's also given to us. Find the angle of projection theta, so we need to find theta. So you got to know the formula, and you need to use simply those formula. That will be sufficient. So formula for maximum height in a projectile is u square sine square theta upon twice g, and the formula for maximum range is u square sine 2 theta upon g. And from here we want to know theta, so we can eliminate u. For that sake we can divide the two. So if we divide this first and the second, I'm dividing directly, you can divide them otherwise. So the u square getting cancelled out, g will get cancelled out, and you will get some sort of this sine square theta divided by 2 will be survived from here into sine 2 theta. And then you can write this sine square theta as the sine theta into sine theta. And you can write this as the sine 2 theta formula. So 2 and 2 will become 4. And this will become sine theta into cos theta. And then you can simplify this, and this you will find this sine theta getting cancelled out. It's becoming 1 by 4 tan theta. So from here we got a result. We will treat it as a result. So tan theta is given by 4h upon r. So you treat it just like a formula. This whenever you need to find the angle of projection from height and range, you directly use this, and that will be true for all the projectile motions that are occurring on the horizontal ground. So here is the next problem, and it reads, prove that a projectile can be thrown at two different angles in the horizontal ground with same speed, so that it has same ranges in the two cases and different maximum heights. So let's start with this. Solution can be like this. We can assume two different angles are theta 1 and theta 2. These are the different angles, and u1, u2, these are the speeds or velocity magnitude. They are equal for the two cases, so let's consider it as u. And what it says, h1 should not be equal to h2. However, r1 is equal to r2. So we will start with this, that given condition is r1 is equal to r2, so we will equate r1 equal to r2. What it is going to give us, so we can put a formula. Formula goes like u square sine 2 theta 1 for the first case divided by g should be equal to u square sine 2 theta 2 divided by g. When we equate this, so we are going to get some sort of this sine 2 theta 1 came out to be equal to sine 2 theta 2, which basically says this is a trigonometric equation which we can solve it. Obvious solution will be theta 1 equal to theta 2, but we are not expecting that. So we know that this can be rewritten as, let's say I'm writing this in a different way. So this can be rewritten as a sine 180 rather, 180 minus 2 pi, 2 theta 2, 180 minus 2 theta 2. So we know any theta can be converted as pi minus theta for sine, so that it remains the sine. Now we can compare the arguments. This argument is equal to this argument. So when we compare these two arguments, we are going to get some sort of this twice theta 1 is equal to pi minus twice theta 2. So from here we will be writing this as 2 theta 1 plus 2 theta 2 is equal to pi. Ultimately you can write it as a theta 1 plus theta 2 is equal to pi by 2. Again, this becomes a result that we can keep in mind for projectile motion on a horizontal ground. That means theta 1, theta 2, we are considering two angles which may be different or which can be different, and still we will be achieving the same range. Now, why there has to be different? Because we want heights to be different. So for height to be different, angles has to be different. So they are different theta 1 and theta 2 are different. So that's how it gets proved. Yes, this is feasible. And what the relation is, this is the relation. Theta 1 plus theta 2 must be equal to 90 degree. If we draw a picture, it would look like this. Let's say they have been projected from point A, lands on point B. So this is projected with U, angle let's say theta 1. This is projected with U, angle let's say theta 2. In both cases you can see this is the range. So range is coming equal, but heights are different. So we can say heights can be made different, keeping the range equal. Okay, and that means there exists two angles for which we can achieve the same range, one by higher height, another by lower height. And these angles should be like this: theta 1 plus theta 2 is equal to pi by 2, that is 90 degree. So that means if theta 1 is given to us 30 degree, we can easily find out what the theta 2 is going to be for the condition when the ranges are equal. So condition is the ranges are equal. So we will say this is going to be 60 degree. Moreover, this is true only if we are throwing them with the same speed. So this is also a condition we need to keep in mind. This is the next example. Let's read it. Find the time after which the velocity of a projectile becomes perpendicular to the velocity of projection. Velocity of projection means initial velocity. So let's say this is the initial velocity, that means velocity of projection, and we need to find the time after which the velocity becomes perpendicular to this. So you'll know at this topmost point the velocity becomes like this, so that's not going to be perpendicular. For it to be perpendicular, it has to be somewhere there. So let's say this is the velocity that becomes perpendicular. For that sake, you need to just draw a tangent. So tangent will be some sort of this. And let's say that velocity is v, and we are claiming these two are perpendicular. So if it is thrown at equal to 0, we need to find what the time it is going to be when it becomes perpendicular. That's a question. And once you got question, you need to solve this by using the equations that you know. So there can be n ways to solve it. I'm going to use the vector method. So v velocity, can we write this v velocity at any instant as a vx I cap and vy j cap? That's how we can write the velocity at any instant. We know the vx, we know the vy. So ultimately it can be written as vx, which is going to be u cos theta, because it does not change. And or I'm simply placing the Vx formula out of the 4 equation of projectiles, and Vy is written as u sin theta minus gt. So that's the velocity in the vertical direction, j cap. So that's the velocity at any instant of time t. And what is the initial velocity? We can write this initial velocity vector as x component, that is u cos theta I, and y component, that is u sin theta j. Or we can simply place t equal to 0 in the above expression. So that will give you the initial velocity. Now our claim is to find that these two velocities has to be perpendicular. And now these are the two vectors, and we know whenever the vectors are perpendicular, we can use the rules of vectors. So since v is to be claimed to be perpendicular to u, that implies if we go for this thing v dot u, that means if we perform the dot product, this must come 0, because we know perpendicular vectors dot product is always 0. Now we can use this property and we can go ahead. Let's do the dot product of these two vectors. You have learned how to get the dot product. So I coefficients going to multiply together. So it's going to be u cos theta whole square, and then multiplication of this z components is going to be u sine theta. That can be as a one factor. Another factor is going to be u sine theta minus gt. This term must be 0. By solving this, we can find out the value of t out of it. So let's try to solve it out. So what it is going to be equal to, when you multiply this term with this, so that will become u square sine square theta. And if you combine with this, so I'm writing it, this u square can be taken common, so it's going to be cos square theta plus sine square theta for the first term of this, and the second term will be minus u sine theta into gt. This has to be 0. Now this can be easily solved. So this will become equal to, from here you get u square, and if we take that terms that side, so it becomes u sine theta into gt. From here the t value can be calculated and remembered for future calculations. So one u is getting cancelled because u cannot be 0, so we can cancel out and divide by g sine theta. So formula comes out to be t is equal to u upon g sine theta. That means after this time, from the initial projection, or from the projection you can call, the velocity will become perpendicular to the initial velocity, right? So this is the velocity which is going to be perpendicular to this. You can try the same equation by using geometry. That means you can produce this. This can be another way. Produce this like this, and produce like this, and then you can measure what this angle makes finally from the horizontal direction. And this angle is given to us. This is going to be 90 degree, and then you can use the triangle or something to find this thing. Or ultimately you need to remember this as a factual information, because in advanced level questions we will be directly using this t, which is u upon g sine theta. Now let's talk about a projectile motion from a height. Till now what we were discussing about was the projectile motion on a horizontal ground. So let's say this is the ground that has been shown over here. That's a ground, and if we throw a particle like this, it follows this kind of projectile path. So that's called projectile motion on the ground. And here we are throwing the particle at a height h above the ground. So if you are h height above the ground and throwing a particle, so there can be n number of directions in which you can throw it. So let's say this is the initial velocity that is being given to the particle, and this is the angle of projection. Angle of projection we measure from the x-axis towards the y-direction line. So we are considering this as our origin, right? So this is origin, this is x direction, this is y direction. And if you consider only this part of the motion, then this is basically exactly similar to the work that we have already talked about. What is the additional part is coming? This is downside, because now the particle has a facility to go downside from this horizontal level, right? So how to describe this motion? Again, I'm going to write the equations of motion, and we will be using those equations of motion to find out the unknown quantity in the equations. So you will divide this motion in the two components. One will be x component of motion, and origin I have chosen, so we will be following sign convention according to this. G is vertically downside always, so that will remain downside. So here initial components or these values, like initial velocity in the horizontal direction, if you look at, or x direction, it's going to be a component of this, which is going to be in this direction. That's a u cos theta. So we are going to write initial velocity as a u cos theta. And if you look at the acceleration in the x direction, that's going to be 0. So you are finding the same parameters in this case as well. Hence equations will be the same. That means at any instant what the velocity in x direction is going to be, it's going to remain constant, so it becomes u cos theta. So initial velocity, whatever is in the x direction, that will remain constant all through. Then x displacement of the particle at any instant of time, so that's going to be u cos theta, which is initial velocity, into t, that is time. So that will become two equations for x component of motion. Similarly, we will talk about the y component of motion. So there will be two equations for y component, and then these four equations will be sufficient to describe the motion. So y component of motion. First of all, we need to find out the velocity acceleration in the y direction. Initial velocity in the x direction is going to be, now you see the initial velocity component in the y direction is going to be this. And this is u sine theta. Now this velocity is in the y direction, which is positive, so we are going to write as a positive u sine theta. And what about this ay? Ay is in working downward direction, you see this acceleration. Hence we are going to write it as a minus g. This minus taking the direction. So we can write the velocity component in the y direction at any instant of time using the formula u plus at. So u sine theta plus at. So in place of a we will write minus g. So that becomes this equation. Similarly, displacement in the y direction, that is going to be equal to ut plus half at square. So u is u sine theta as a plus, t is always positive, minus half g t square. Why I'm writing minus g? Because of this ay, so half ay t square. So that will make this. So these four equations are equations of motion for the projectile thrown from a height. Look these equations carefully, you'll find they are exactly the same equations that we already drawn for the case of horizontal case. So they are exactly same equations. What is going to be the difference is the conditions that we are going to apply. There's no difference in the equations as such. Make sense? Now let's say we need to find how long it will take to land on the ground, or maybe any other thing. So let's say we have thrown it equal to 0 and we wanted to find this value t equal to t, the time of flight. So how we can use it? Can we say when the particle is going to land on the ground, one parameter out of these four we know. What we know is from here it is started. Let me use another color. From here it is started and lands here. That means y displacement. Displacement in the y direction is this. So that will be the displacement of the particle in t time, and that's a y coordinate, and that's equal to h. So can we say, this is just an example, or basically a formula will also come out of it. So we can say when y becomes equal to minus h. Why I'm writing minus h? Because this is origin and displacement is downside for this particular location, or you can think of the coordinate of this y coordinate. When this y is this, you will find then t will be capital T. So you need to search an equation out of these four in which y and t are related. And once you look at this y, you will find this fourth equation is going to be useful. So in place of y this minus h, so equation will become minus h is equal to u sine theta into t minus half g t square. And this is a quadratic on time. If h is given in terms of number, so h can be used. If u is given in terms of number, theta is given in terms of number, g is a number. So we can find this is going to be a quadratic equation in t. And from here we can easily find out what the t is. That means we can find out how much time it's going to take to land on the ground. Right. Similarly, we can work for other parameters. So point is, vectors has to be taken care of, and the direction of vectors can be incorporated by using the minus later. Makes sense? Moreover, this is a general case again from any height case. This theta, whatever the theta that you are able to see over here, this theta can be changed, right? So if we place this theta equal to 0, let's say somebody says theta equal to 0, that means particle is being thrown horizontally from a height. Right, so all the equations can be achieved for horizontal throw if we place theta equal to 0 in these expressions. Similarly, this will be also helpful to solve those questions if the particle is being thrown downside like this. So we measure this theta positive in the upward direction. So what we are going to measure, theta is going to be measured as a negative. So if the particle is being thrown downwards, so simply what we need to do, we need to replace theta by minus theta. So that theta has to be taken negative, and it will talk about all the cases in which the particle is being thrown maybe like this and it's following this kind of path. So these formulas are very general, and that can be used for all thetas. Here the theta is being measured in this sense, that we need to keep in mind, and that's a positive. If it comes downside, that becomes negative, and for theta equal to 0, that becomes the popular motion, horizontal projectile from a height. Okay, so let's consider this example to use the equations that we have just formed for projectile from a height. So it says a projectile is thrown from a building of height 20 meters. So height is given as a 20 meter. Horizontal direction, so that's being thrown in horizontal direction. So we can start from here. Let's say a particle is there, and that is being thrown in a horizontal direction like this. So that horizontal direction, as you say, that means you are saying theta is 0. So okay, theta is being 0, so it's horizontal direction, and thus velocity is given to us as a 10 meter per second. So u is given to us. Furthermore, it says find the time taken by particle to reach the ground and distance from the bottom of the building. So how the path of this particle is going to be, that's also going to be a parabolic projectile, and it's going to land somewhere like this. So this is going to be the path of it. Let's say the point from where you have thrown it, this point is A, and this is B, bottom of the building, and C is where it lands. So some obvious questions that is always can be asked are like how long it takes to go there, that means time. So if it is starting at t equal to 0, so let's say it takes time t equal to capital T to reach there. So one thing is this we need to find. Next could be to find this x distance, the distance between B and C. That's this question is demanding. H is given to us. Other points can be asked like when the particle is at a particular height, then tell me what the velocity is and if their components are, and its displacement is, and also it can be asked what is the final displacement. So this shortest distance we can calculate. If we know h and x, we can find that as well. Anyway, so in case we want to solve these questions that has been asked over here, so what we need to do, we need to use the equations that we have solved it. First we need to find this t. How we can find this t? What is given to us? We have been given this h value. So we will be considering this A point as origin. We will be considering this direction as x direction, positive x, and this direction as a positive y. So if you are considering this A as an origin point, then of course this displacement finally in the y direction is going to be this, which is going to be negative. So point is we need to write this y as minus h, which is basically 20, so it's going to be minus 20 meters. So y is minus 20 meter, and then time will become capital T. So we can borrow the fourth equation. If you remember the fourth equation, that was y is equal to u sine theta t minus half gt square, Let me use this red color. So here theta is also obviously clear. Theta is 0 for horizontal case. So we can put the theta 0 and place this y as minus 20. So this becomes minus 20 is equal to 0 because theta is 0, hence everything will become 0, minus half, g is a number which is 10 into t square. By simplifying this equation, we can find this t, where this t small t can also be represented as a capital T because this is the total time of flight. So from here we can find this capital T. How much that capital T is going to be? T square is equal to minus and minus get cancelled out because t square has to be a positive number. So this will come 5, so 20 by 5, that becomes 4. So from here we can find the t value is going to be plus minus 2. Of course negative time is not acceptable, so t is equal to 2 seconds. So after 2 seconds you'll find this particle will land on the ground if it is being thrown at a height of 20 meters. Makes sense? And then it is asking for find the x, that's the horizontal range. So can we say this x is going to be used from the equation, out of 4 equations there was equation for x, and that was u cos theta into t. Now if this x is over the capital time t, so we can say we can replace this t by capital T, so that becomes the formula for h as well. As for formula for x, that's a horizontal range. So what this x is going to be equal to, place the value of u, which is 10, place the value of theta, which is 0, place the value of t that we have calculated is 2, cos 0 is 1, so x will come out to be 20 meter. So from here we are able to find the horizontal range as well as the time it took to achieve that range. If it is asking for the displacement, use this Pythagoras, you can find the displacement. However, finding the distance is quite complicated, so we will be learning that formula later on. So here I have just tried to explain how we can use those 4 equations. No matter what the theta is, if it is given to us, we can use it. And sign conventions are important. If we are having a displacement downside, so it has to be written negative, and acceleration was also downside, so we have written it as a minus g. So these minus and minus getting cancelled out, and we are able to simplify it. Now, as I have told you earlier, you can choose your coordinate system differently, and then you will be finding a different sign notations, but ultimately you will get the same equation and the same answer, because our answer does not depend on the frame of, on the coordinate system that we use. It has to be independent of the coordinate system. Fine. Here is another question, and it says a particle is released from a height and another is thrown horizontally from the same point at the same instant. Compare the time taken by the 2 particles to reach the ground. So let's say this is particle 1, this is particle number 2. One particle is being dropped, another is being thrown with a horizontal velocity. Now the path of this first particle is going to be vertically downside, so that's the 1D motion. Path of the second is going to be projectile, like this, it's going to land over here. Both will hit the ground after a certain time. Let's say T1 is the time taken by the first, T2 is the time taken by the second in this entire journey. They started at the same location and at the same moment of time. And let's say they have a different masses, so M1 is, let's say, heavier than M2. So that is given to us. We need to find, we need to compare T1 and T2. So I'm giving you 4 options. Option A, T1 is equal to T2. Option B, T1 is greater than T2. T1 and T2, they are the time, yeah. So C, this says T1 is less than T2. And D says any of them is possible. Any of them is possible. So you need to mark the correct option. So I'm making this as a homework. So this example has been made as a homework. So you solve and let me know which one is going to be the correct answer. So give this answer in the comment section. Fine. So this is related to both vertically downside motion and horizontal projectile motion from a height. We can use those concepts and find T1 and T2 and simplify it. Well, so that's for all in this video. In this video we have talked about some examples and general case for any motion from a height, and if you have got those equations well, you can use those equations to find out the equations when a particle is being thrown from a height. Okay, thank you for watching. Have a great time.